Very conscious I'm the one between you and here and everyone's lunch, so I won't keep anyone waiting. I'm just here to talk about the Mercer Institute for Successful Ageing project that was completed in St James's Hospital in Dublin. Just give you a quick introduction to who we are, and then maybe just talk through the project and how we went about applying BIM to it. So for those who aren't familiar with us, we're a consulting civil and structural engineering firm. We're around for 78 years, established in 1937, and we have a number of locations throughout Ireland and also internationally. We offer a number of services: civil and structural engineering, assigned certifier, PSDP, PSCS, project management and economic development. We cross most sectors in the construction industry, being around for 78 years, you don't really avoid them, a number of which have been award-winning. We've worked in over 35 countries internationally so far. This was the biggest or most photogenic photos I could fit on, or projects I could fit onto one slide. So we've worked in a number of large pharmaceutical, healthcare, educational projects throughout Ireland and abroad. And again, I tried to pack as many 3D models as I possibly could onto a slide. Delighted to say I have more models in reserve. Thankfully found out that we have more models than I can fit on one PowerPoint slide. So for Mercer for Institute for Successful Ageing, it was one of our first collaborative projects that we delivered in our organisation to an agreed standard, and that's our rendered version of the structural model. We have to apologise to all the architects for our rendering skills as we go through the presentation. It was completed in St James's Hospital in Dublin, as I said. It was a 40 million design and build project constructed by BAM. We were working for BAM on the design build side, and they were our client of the project. There was a technical advisor team on the other side working and advising the client of the project. It varies in height throughout its floor plan. It's 7 stories at its highest, but also there's 4-story and 2-story sections. We're delighted to say the project is now complete. It was an in-situ reinforced concrete below-ground structure, and the vertical structure was again in-situ concrete. All the horizontal structure was a post-tension concrete with steelwork frame for the roof plantrums you see in some of the renders. The facility contains 100 beds, so I'm sure we'll fit as many as we need into it, Bill and David, and 15,000 square metres. So they're just a couple of the renders of what we thought when we were finished or close to finishing or had started our design that it might look like. Just a couple of photos of it being constructed, and we're delighted to say the model represented more or less what we had thought, thankfully. Thanks, BAM. And finally, it was finished, and these are some of the final finished photos for the project. As you can see, it has some very interesting features. It was carried out in a very restricted live acute hospital healthcare campus, which is about to get more restricted and congested, as we all know, with the National Children's Hospital. So the floor plate for the building actually increased at 3rd floor level. So we had a bigger structure at 3rd floor level than we had at ground floor level. As I mentioned, it was a restricted site. There was no existing underground car park. There was neighbouring buildings with overhangs and projections all around it. And to try and combat that, we used, and point cloud survey was utilised to try and make sure that we were fully appreciated the environment that was around us. And I believe led us to figure out that we actually had a bigger projection on some of the buildings at a higher level than had been envisaged, such as projections as the ones we had created. So as you can see, between the existing buildings on the photos, it was a very tight environment, and BIM was utilised to try and create any advantage we could, and BAM could, to try and make sure that we were getting things right first time and that things were going to work when we got to site. Some other innovations on the project was our use of biodirectional workflow between the physical model we created and the analytical model that we used to size the structural elements on the project. We have definitely improved that process since we started this project, and it's working better now than it did when we were doing the MISA project. We kind of use it at a basic level for the MISA project for some of the more complex and not straightforward sections, and also that played a part in the time constraints and program we had to deliver our information to. The project was started in late 2013, early 2014, so we think it's one of the first projects completed to PAS 1192 in Ireland. I'm happy to stand corrected if anyone wants to point me in another direction. And it was definitely our first project that we completed in a fully collaborative environment to an agreed international standard or UK standard. I think everyone in this room realises that communication, coordination, cooperation is essential to the delivery of any successful project, especially one in a healthcare environment and in such a restricted environment and with the neighbouring buildings. Collaboration system as a CDE was used, business collaborator by BAM, set up by BAM, and everyone started getting used to what it meant to apply PAS 1192 on a real project, and in one that was actually being used, particularly the file name to PAS, which we had to convince and coax some of our technicians to get used to. But at the end of the project, they realised why it was the way it was, why it should be the way it is, and now that we're using PAS 1192 naming systems in most projects that we deliver. A big tool with the use of BIM, as everyone has kind of pointed out in the projects you've seen so far, is the visualization and the ability for us and BAM and other design team members on the project to show the client and those not informed or other stakeholders not informed with the construction process what it actually means, what we're saying, what we're trying to show them on a 2D drawing. To show them in 3D, to walk them through a building just makes a big difference to what their understanding is and getting buy-in from them, and also that they make sure that they get what they want. I think as all the other projects have featured, class detection and coordination and meetings around them was again essential part of our communication and collaboration strategy on the project. A number of meetings were held, be it fortnightly on site or online, weekly, or by phone or by email, or whatever it took to resolve and identify clashes. We had a task information manager who worked very closely with the project information manager within BAM. BIM execution plan was prepared to the project to PAS 1192, and that's what we worked to and how we carried out our work, primarily between the main designers on BAM side, ourselves, BDP, and O'Connell Mahon. We used and worked through Revit files, which were federated in Navisworks, which were also used in Glue 360, and which operatives on the site used in Field 360. Again, a big use of Glue 360 was just identifying and highlighting areas where there was issues that needed to be discussed, developed, and organised. Again, just like a lot of other presenters so far today, IFC played a part where other people weren't using Revit, such as the structural steel supplier and contractor. They were using Tekla, models and information was changed by IFC. I mentioned before, everything was done to PAS 1192 as best as we knew it or could at the time. I think we definitely do things a little different now, and maybe the stuff we thought that was in compliance during this project maybe isn't, but I think we've definitely learned and have, as a result of this project, really developed our understanding of that standard and what it means to apply to a project. The project was started kind of 2 or 3 years before the UK BIM mandate, and as I mentioned, it was one of our first fully collaborative projects. A lot of our staff had to undergo a number of formal training days to kind of start our process through making sure that we were doing things right from the start of the project. But that was really only the start of it for a lot of our staff. There was a lot of self and shared learning, and we're delighted to work on the project with similar-minded people in the contractor and other design team members. We were open and willing to learn, to realise that we didn't know everything, or to try and show that we didn't know everything, and try and share and get everyone through what we knew or didn't know at the time. And as always, I think YouTube and Google was our friend as we learned throughout the process. I think coming up later on, but a lot of the stuff we were finding was that if something was done a particular way, it didn't work for us, particularly in the transition between the physical model and the structural and integral model. And it was about our engineers educating our technical staff or technicians on, and model builders on, the correct way to do something. Just feeding back that the way you did it yesterday didn't work because the model fell apart when I transferred it. Do it the way you did it 2 days ago, and that will work for me. So we were doing that internally as well as externally, with understanding what way the architect wanted the information, what way the MEP engineer wanted their information. And I think the application of BIM was the risk management strategy. It was a challenging building on a challenging site, and everything we were doing in regards to visualization, communication and collaboration, they were the risk management strategies and how we were delivering the project first time as best we could. One of the best project outcomes we had was that it was constructed. It was finished, much to the relief of a lot of our people in our organisation and office, and that we finally got through and we got it built. And we're delighted that, having learned the lessons on this, that we can apply them to our future projects. And we were also delighted that when we asked for references on the project, that we really got some good feedback from BAM, our client, from St James's Hospital, their client. So it's always good and nice to hear some good things about the work you have done. I have to apologise for a number of people in the room, probably seen this presentation at least twice or three times. We've shared our knowledge through professional body organisation and industry events on what we've learned through this project in the CR Smarter series, Rivet user events, and on the London Digital Show. So we're quite happy and willing to share our knowledge with anyone who can put up with listening to me any further than 15 minutes. What we've tried to impart on people is what worked for us, what we did well, and what was a good outcome, but also what didn't work. We openly admit that we really didn't get the structural analysis bidirectional flow working on the model, but we got the bits we wanted to work right. We've definitely learned lessons, and we've definitely been taking things into the future as a result of this project. So some of our key learnings was how to improve our drawing quality from when we started on the project and using our authoring tool Revit. We really learned about PAS 1192 and what it meant to apply it in real life on our real project instead of just interpreting and reading the text of a standard. We started to learn about the data and the amount of information that was being generated and how that had to be managed and the workflows and flows around that information and where that needed to go. Number one, within our organisation, but also within the other stakeholders within the project. We definitely learned that our technicians were becoming more involved in projects. They were no longer behind an engineer, the outward-facing person in the organisation. Our lead technicians on the project, our model authors, they were attending meetings, they were going to site more often, they were being more involved with our external stakeholders from our organisation. I think one of the biggest things we learned is that it took us more time earlier on, and we had to put more effort in earlier on to get what we needed to do and what others needed from us. So definitely earlier on in the project we had to put more work and effort into. But that, as we've heard maybe from others, that kind of started paying back when a change was requested. Having the model built earlier on meant that we could adapt and react to changes in a more timely and more efficient manner. So what we've been working on since, one of the biggest lessons we learned was when to detail and what not to detail and what to detail, making sure that the information, we weren't wasting time putting unnecessary information into the model, and number two, that we were putting the information in at the right time, that we weren't wasting our effort at the wrong point in the project. It has informed our internal procedures and our QA procedures to ensure that we're complying with PAS 1192 and other standards. We've definitely been beating into technicians that they need to respect the analytical model and the nodes that are created in the physical model, and any new technician that walks in the door, that's generally the first thing on their induction. And we've been generating our templates the whole time to make sure that we can comply as a rule rather than as a necessity. Thanks.